Hi, my name is Sweenig, and this video is an overview of the process of configuring NetVoyant to poll a metric not available out of the box. My blog at stuart.weenig.com has tips, tricks, and best practices about all the products in CA's NetQS suite. I currently serve as the Communications Officer for the CA Infrastructure Management Global User Community, and you may already know that I'm available on the community for assistance or for any questions that you may have. I've been working with all the NetQS products since 2006 with installations at over 200 different customer sites. In order to understand custom polling, we need to understand the role of datasets in NetVoyant. All datasets, whether out of the box or custom built, function exactly the same way. One benefit to this is that you can look at the out-of-the-box dataset configurations to get ideas about how you can build your own. Now, datasets are the central hub for data in NetVoyant. They define which OIDs to poll. They mathematically transform the data into something more user-friendly through expressions. They store the data in the database. They determine poll instance names. Through datasets, you can exclude certain poll instances from discovery or disable certain poll instances after discovery. And they also determine how data is rolled up. And once the data is in the database, it can be displayed in the NetVoyant Web GUI or in NPC through views, which I'll go into later. While we're on the topic of rollups, we should discuss how rollups work. NetVoyant collects data from OIDs as defined in the dataset expressions and stores that in the database as poll rate data. As soon as enough poll rate data has been collected to cover a rollup period, the smallest rollup period being an hour, NetVoyant calculates a single data point to summarize that time period. That single data point is by default an average of the data points in the poll rate data for that time period. When you're building a custom data set or even modifying the default data sets, you can also specify an additional roll-up calculation besides the average, like 95th percentile, maximum, standard deviation. The roll-up process repeats for larger and larger roll-up periods. So let's take an example. NetVoyant may be polling a certain metric every 5 minutes. That means 12 poll rate data points in 1 hour. After that hour, NetVoyant will calculate the average of those 12 data points. We can also configure NetVoyant to calculate, let's say, the 95th percentile of those 12 data points. Now, once 24 hours has passed, we will have 288 poll rate data points and 24 hourly data points, or 48 if we configured the additional rollup calculation. At the 24-hour mark, NetVoyant will calculate the average of those 24 hourly points to result in one daily data point. Now, if we've configured an additional rollup calculation, it will also calculate that rollup. The dataset contains a configuration around which rollups to calculate and how long to retain each level of data. Now, most of the time, poll rate data is only kept for a couple of weeks. Daily data is kept for a month or 3, and longer rollups have much longer retention settings. The basic steps for configuring custom polling in NetVoyant are shown here. Now that we know that one of the main functions of a dataset is to translate the raw data from the MIB into usable data, it should make sense that the first 3 steps in configuring custom polling involve looking at the raw data and figuring out how that data needs to be transformed into something usable. The rest of the steps can often use the defaults until you want to get really fancy. This list is what I'll refer to whenever I'm building a custom polling into NetVoyant. The MIB browser allows you to poll raw OIDs from a MIB table and see the values returned. So in this case, we can see that one of the Dell PowerEdge MIBs was compiled, and the MIB browser is actively polling some temperature probe OIDs. One table had these 2 columns in it, temperature probe location name and temperature probe reading. Selecting the value 260 under the temperature probe reading column in the MIB browser and clicking the ellipses in the toolbar brings up the description of that OID as defined in the MIB file. So in this case, the description indicates that this OID returns the temperature in tenths of a degree Celsius. So in order to convert to degrees Celsius, we first have to divide by 10, and from there it's pretty easy to convert to Fahrenheit. Now another OID, temperature probe status, could tell us the status of the probe itself to make sure that it wasn't malfunctioning or not present. The avail expression uses that OID to determine if the probe is in a good, 100, or bad, 0 status. And this can be used to send out an alarm when the probe fails, or if multiple probes are listed but are not present, we could use a discovery rule to prevent the absent probes from showing up. Once we've got the expressions defined, we can proceed to actually configure the dataset. Now, two important options to consider are the model field and the poll instance naming fields. The model field allows you to specify that when a device is being discovered, this dataset will only be attempted if the device is of a certain type. This allows you to specify that datasets that only pertain to routers only be attempted on routers. This optimizes discovery by skipping the devices we know won't respond. The poll instance name and description fields are important. Now remember how the MIB browser showed us that the value of the temperature probe location name was, quote, system board ambient temp? Well, we can statically define the name of our poll instances, or we can use a reference to an OID so that the poll instance name comes from the MIB. Now, this is particularly handy if you have multiple probes. You wouldn't want all of them to be called system board ambient temp or temperature probe or thermometer. It'd be nice if the name that the manufacturer provided could come through and be displayed in NetVoyant. Poll groups simply determine at what rates poll instances belonging to this dataset can be polled. So I usually set up 3, but always at least 2, 1 minute and 5 minutes. I set the auto enable to 5 minutes because that's what I eventually want to use for my poll rate, but I have 1 minute configured and available that I can use during testing. It's not required, but you can configure some advanced calculations. Now, these advanced calculations are performed when the data is rolled up. Now, by default, average is selected. This means that the roll-up is the average of the higher resolution data, the poll rate data, for example. However, you can specify that a maximum, minimum, standard deviation, variation, or percentile be calculated, or you can specify all of them. You can also have NetVoyant sum the data points for the rollup. Now, this is handy when the data is volumetric, like bytes, instead of rate, like bits per second. That way, each poll rate data point adds to the hourly total. In order to calculate the sum, you have to disable all advanced calculations. Discovery and auto-enable rules are helpful when you're trying to keep things clean and running efficiently. Now, discovery rules test OID values against a rule during discovery. If the rule evaluates to true, the poll instance is discovered. If not, NetVoyant aborts discovery of that poll instance and moves on to the next one. Now, discovery rules are handy when you're trying to prevent unnecessary poll instances from even showing up in the system. An example of this would be the CPU table from the UC Davis MIB. The CPU table in that MIB defines 3 poll instances, one for the 1 minute load average, one for the 5 minute load average, and one for the 15 minute load average. Now, depending on poll rate, synchronization of clocks, it can be kind of difficult to poll the right one. Most NetVoyant administrators choose the 1 minute average and settle for that being a sample of the CPU load average. Now, this means that the other 2 poll instances are completely unnecessary. A discovery rule can be used to prevent them from being discovered, which prevents them from showing up in any searches or in the NetVoyant console. Auto-enable rules take effect after discovery and are used to automatically disable poll instances that we want discovered but not polled. A good example of this would be the various types of non-IP-based interfaces that aren't of much interest. We may want NetVoyant to know about these interfaces so that we can know that they're there, but we don't necessarily want to spend poll cycle resources polling them. An auto-enable rule allows us to inspect the interface, or any poll instance really, and disable it until it meets certain criteria. Now, after building the dataset, we need to see if our configuration is good. The first step in checking is to rediscover a device that should have poll instances in this new dataset. Check to make sure discovery finishes without any errors, and that the name and description show up the way you want them to. You'll also want to make sure that any auto-enable rules and discovery rules actually worked the way you wanted them to. At this point, I usually pick a few poll instances on that test device and configure them for 1 minute polling so that I start getting data right away. When this whole process is done, I can set it back to the default for these poll instances. Now that the poll instances are discovered and NetVoyant is collecting data for them, we need to start looking at the data. At this point, I would recommend that you jailbreak NPC and use the custom view wizard directly in NPC. Now, there are some disadvantages to it. For example, it's not as easy to delete views from NPC as it is in NetVoyant, but the benefits are worth it. I'll be presenting the next few slides as if you've jailbroken NPC, but the same concepts apply in the NetVoyant web GUI since they're basically the same code underneath. Now, there are essentially 3 locations or levels of detail in NPC called contexts. Each context level has an associated set of pages. Best example of a poll instance context is the interface context. When you drill into an interface in NPC, you're taken to a set of pages that all focus on the performance of that single interface. The same applies to any type of poll instance. Now, the device level context views focus on multiple poll instances all belonging to the same device. The group and site level contexts are essentially the same as the device level context, except all the poll instances belong to the same group or site. Each view in NPC has a setting that defines what type of context it applies to. The cool thing is that many views can apply to multiple contexts. For example, the top interface utilization table can be viewed on the device level, showing all interfaces on the device, or it can be shown on the group or site level, showing all interfaces in the group or site. Now, this is important to understand because the process of building views will involve changing the default context of a device level view so that it can also be used on a group level page. When creating a view, the context for the view is set to the page you were on when you launched the wizard. So, to build the poll instance view, you'll need to be on the poll instance page. In NPC, the easiest way to do this is to search for the test device, then go to the device details page. Then click on the poll instance in the poll instance list view. If you don't have the poll instance list view there, edit the details page and put it on there. It's a good thing to have. Now, the first type of view I always build is a trend plot. This lets me look at the data collected and is most likely the view that I'll want on the poll instance page. Now, when someone drills into a poll instance, they'll want to see how my metrics trend over time. Now, there are a couple of things I do to each trend view. One, I set the footer to display the current number of data points and the resolution. 2, sometimes I plot multiple expressions on the same trend plot, and I sometimes use the right y-axis. And by the way, whenever you're plotting availability, it should be plotted as a stacked area trend plot with unavailability derived right in the view definition, which is just 100 minus the availability. Now, review the data in the trend plot to make sure it looks right, and if any changes need to be made to the expressions, go back to the dataset and make them at this point. Once the poll instance context view is built, use the breadcrumb feature to get up to the device context page. A table view will show a list of all the poll instances on the device, allow drill down to the poll instance, while at the same time allowing you to display roll-up data on all the expressions for that poll instance. When you drill down, you should see views on the poll instance page for all the columns in this table. So if you have degrees Fahrenheit and availability, then when you drill down, you should have a view for degrees Fahrenheit and a view for availability. Now, this view is perfect for any group context as well, but the default context for the view will be the device level context. Now, in order to fix this, you'll need some MySQL experience, but it's not too difficult. Post a comment asking for the details if you're interested. If you don't want to bother with modifying the database directly, you can still rebuild this exact same view on the group context level. For me, it's easier to just go into the database rather than to build the exact same view twice. So, you could also build a multi-poll instance trend plot. Now, this will draw one line for every poll instance. Now, the only problem with this is that you are limited to one expression per view. Now, the only difference with a group or site level view is that you may want to drill down to take the user to the device level instead of directly to the poll instance level, skipping over the information about the device's other poll instances. Now, to do this, whether you've rebuilt the device view manually or by using the database shortcut, edit the view and change the drill down to S, D, SW, or R, depending on which device type page you want to drill down to: server, device, switch, or router. If you built the view manually, save the view as default for all users. If you use the shortcut, save the changes to this location for all users. The difference has to do with view instances. Now, each view in NPC has a default definition. Now, when you put a view on a page and location-specific instance of the view is created. That instance, at first, uses the default definition. Now, this is handy because the same view can be used all over NPC, and if you wanted to make a change to all of them, all you'd have to do is edit the default view definition. To edit the default view definition, simply edit the view in the wizard, then when it comes time to save the view, select Default for all users. You can modify the location instance of the view as well, independently from the default definition, so that you can tweak one little thing from the default. Best example of this is when you want to put the same view on a page multiple times, but each instance of the view is filtered to a different group. So when you edit the view in this way, save the changes to view location for all users. You can also modify the location instance of the view and save the changes to that location, but only yourself. Now this is handy if you want the view to look one way for most people, but differently for you. Now if you want to do this, save the changes to view location for my user account. You also have the option of saving changes only to your session. Now this is handy if you want to try something out but not save it permanently. The Revert to Default button will appear in the wizard anytime the view definition differs from the default. Now this button erases all the customizations you can see and reverts the view to the default definition. Now here are a couple of tips I've acquired over the years when creating a view. First of all, use view categories. When you're creating the view category determines where it shows up in the list on the left-hand side of the page when you're editing a page. So you'll want to use those and make them nice and meaningful. Don't leave it as the default custom view. Tip number 2, use auto scale and the scale variable in the axis title. This is really handy, especially if you're doing something like bits or bytes or anything that has a unit associated with it. Particularly because if you use that auto scale and scale feature, then the y-axis will automatically add the kilo or the mega or the giga in front of the unit so that it's a lot easier to understand what numbers are there. Tip number 3, use the resolution and samples variables in the footer of trend plots. So if you've got a trend plot, put resolution and samples down there so that you know exactly how many data points you're talking about and at what resolution they are. For availability, use stacked area charts. Don't go to the dataset and create an expression for unavailability. Calculate that right in the view expression. There's no need to calculate that every 5 minutes. It's a really easy derivation that you can just pull right into the view. Lastly, if you've got a trend, display the baseline. It's always good to have a baseline, and it helps you know when things deviate from normal. So this has been my presentation on custom polling in NetVoyant. I hope this video has been helpful. Subscribe to my blog at stuart.weenig.com for more videos to come in the future. Thanks and have a great day.